Hello again. This is Shannon Gracie for Beginning Algebra out of the Blitzer combo book. And we are now on section 1.5, which is the addition of real numbers. So our goals for 1.5 are to be able to add numbers with a number line, find sums using identity and inverse properties, add numbers without a number line, of course, use addition rules to simplify algebraic expressions, and solve applied problems using a series of addition. So here we go. I thought we'd warm up using this problem here. Okay, so just imagine it's Sunday during the fall semester. You're watching the Chargers-Raider game. So what do you think? You Chargers or Raider fan? That's what I thought, Chargers, right? Okay, the Chargers are currently on their own 30-yard line. So for those of you not familiar with football, right, basically the Chargers, this is their end zone, and their own 30-yard line is going to be here. They're trying to get to the Raider end zone so they can score. And then, obviously, they're trying to keep the Raiders from going over here. Right? So the Chargers are currently on their own 30-yard line. During the first down, the first play, that the Chargers have possession of the ball, they complete a pass and they get a gain of 10 yards. And on the second down, the Raiders sack the Chargers quarterback. So when a quarterback is hanging back for a pass, they typically run back, sometimes 5-10 yards. And a sack means that the other team tackles the quarterback before the quarterback can pass or hand off the ball. So here we go. When they sacked the Chargers quarterback, they caused a loss of 10 yards. So what we want to do is use the image of the football field to model the gain and loss of yardage. So if we just check this out, and if we put a marker, where the ball starts, so this is the 30-yard line for the Chargers, and then we can model this, right, by saying, oh, okay, we went 10 yards, and then the end position was here. Now, in the next play, we'll do this one in blue. Let's just say the Chargers ball starts here. And then if they're losing yardage, they're going back towards their own, they're going back towards their own end zone. And the ball ends up right here. So that's a model for this situation. Okay? So let's go ahead and answer this. So how would you use signed numbers to represent the 10-yard gain? Well, it's a gain, so it's positive, and then it's 10, and we can put that unit as yards. Now, what is the next part, C, how would we use signed numbers to represent the 10-yard loss? Well, it's a loss, so it's a negative, and then again, it's 10 yards. So what would you guys say that the net yardage gained is? Good. They ended up in the same spot they started from, so 0 yards. Good so far? Feeling warmed up? Awesome. All right. So here we go. The next part, how could we use the number line, right, to model 10 plus negative 10? So in this case, right, our center in the football field is 50, right? So if you think about this, it's going to be a little different situation. But didn't we really take a positive 10 and add to that a negative 10? So that's why I put this problem up here. So 10 plus negative 10, we can start out by, some people sort of leapfrog over. So they kind of they leapfrog and they go 1, 2, 3, 4, all the way to 10. You can start with 0, you can go over to model this first part is modeling 10. And then when you're adding a negative 10, you start up here. Whoops. You start up here where you ended off, and then you go to the left, because adding a negative 10 means you're adding the opposite of 10, and you end up over here. So the number that we ended up on was, of course, 0. So based on this information above, so what we found out was that 10 plus the opposite of 10 is 0, right? And based on this information, we can conclude that a number and its opposite sum to 0. Oh, I can't write today. Oh, here we go. Okay? Alrighty, so here we go. Starting the lesson, identity and inverse properties of addition. So here we go. The identity property of addition means that 0 can be deleted from a sum. Okay. So here's an example. 1 plus 0 is just 1, isn't it? So basically we've deleted 0 from a sum. Now if you want to bring a variable into it, let's say we had 1 plus x plus the opposite of x, and that would be 1 plus 0, which indeed, as we saw above, is 1. Okay. So here we go. The inverse property of addition, we actually illustrated it above in that problem. Right? The sum, in that second example, we illustrated it, of a real number and its opposite and that's also known as additive inverse, gives 0. The additive identity. So here, this x plus negative x business that we did up here is an illustration of, and that being equal to 0, is an illustration of this inverse property of addition. So examples, we can say that 10 and negative 10 are additive inverses since 10 plus negative 10 equals 0. Okay, so here we go. Adding integers. There's some different models for adding integers, right? So let's just say that the integers that we have are, a plus b. Okay. So for number line models, let a and b represent real numbers. Okay. So first off, you start, one way to do it is to start at a. Then secondly, there's different situations. If B is positive, move B units to the right. If B is negative, move B units to the left. And then, third situation, if B is 0, stay at A. So that's how one would use a number line model. Okay, so let's go ahead and take a look at example 1. And we'll come back, don't worry, we'll come back to the positive negative chip model. So example 1, illustrate 4 plus 2 using a number line, first off. So here we go. Following exactly the directions that we were given, you start at 4, because that's our A, that's the first number. And then we're going to go 2 to the right, and we end up at 6. So 6 is the result for 4 plus 2. That's equal to 6. Okay. Now, let's talk about the positive negative chip model. All right, so here we go. The positive represents one positive. And then this guy represents one negative. And remember from what we learned on the 10 plus negative 10, one positive and one negative results in 0. Okay. So the steps for this one are you draw a picture of A, and then secondly, draw another picture which includes, actually, you know, I think we should say which represents A and B. And then thirdly, you remove pairs of positive and negatives. So if you have one positive, one negative, you just take that bad boy out. Okay? They're going to go run away together. They're going off to Vegas. So let's go down here and represent the positive negative chip method. So here you just start out by drawing your A. So our A this time is 4, and it's positive 4. So we'll write the 4 positives. Okay, so next up, we want to represent the 4 positives And then we also want to represent the two positives that shows us B. And notice that we have our result. There's no pairs, so 4 plus 2 is positive 6. All right. Well, I did the first one, is fairly straightforward since they're both positives. So let's talk about what is the rule for a positive plus a positive. So one way we can write this is we could say add the absolute values. And then to use the common sign, which is a positive, as the sign of the sum. All right, so why don't you go ahead and pause the movie and work on example 2, and then we'll do it together. Okay, let's see how you did. So here our A is negative 2, so we'll make a dot at the negative 2. We are adding a negative 3. So remember that when your B is negative, you're moving to the left. So 1, 2, 3 to the left gives us negative 5. So negative 2 plus negative 3 is negative 5. So the positive negative chip model, we would have our A was negative 2, so there's 2 negatives. And then our next box, we represent our 2 negatives. Then we picture what negative 3 looks like. There's no pairs, so negative 2 plus negative 3 equals negative 5. So what could our rule be? I mean, if you think about it, doesn't our rule for the first one, the positive plus a positive, work for this guy? Think about it. The absolute value of negative 2 is 2. The absolute value of negative 5 is 5. Oh, and thank you. I'm glad I went over this, making up my own math again. This was plus negative 3. There we go. So the absolute value of negative 3 is 3. So if we took 2 plus 3, we would get 5. And then the common sign is a negative. So you know what? It works. This is the same. In fact, if you don't mind, I am going to copy and paste because it's the same rule. Oops, we don't want that one. Oh, we've got the same rule for each of these. Okay? Alrighty. So now, why don't you go ahead, pause the movie, and work on example 3. Okay, let's see how you did. This time our A is negative 10. So we're going to go way over here, and we're going to put a marker at negative 10. We are adding 6. So that means we're moving 1, 2, 3, 4, 5, 6 to the right. So we end up at negative 4. So negative 10 plus 6 equals negative 4. All right, so for a positive negative chip model, we've got 10 negatives. So here is our first box. And then, now we want to represent both of them. And I guess you could do this in, one box. It just depends. I just got used to separating them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's our negative 10. Now we want to put in 6 positives. And I'll put one more positive here. Okay? All right, so we've got some, spring must be in the air, because look at all these. We found all these people that fell in love, and now they're running off to Vegas. So we've got these guys are going away. These guys are leaving. These guys are going. All these happy, happy times. All running away. And our end result, what do we get? At the end of the day, we just have 4 negatives. Do you see? So, negative 10 plus 6 has a result of negative 4. So what would you guys say the rule for a negative plus a positive? What did we do? If you think about their absolute values, didn't we really subtract, right? So here what we did is we subtract the smaller absolute value from the larger absolute value and then use the sign of the number with the larger absolute value. Okay, so let's check this one out. We have a 1 plus a negative 7. So we start here at 1, and then good, we need to move to the left. 1, 2, 3, 4, 5, 6, 7. And here we go. We end up at negative 6. So 1 plus negative 7 equals negative 6. So the positive negative chip model, well, we would just start out with our 1 positive, and then we add in our 7 negatives. So we have our 1 positive, and then we have 1, 2, 3, 4, 5, 6, 7 negatives. And then this time, we only have 1 happy couple that are running away. And notice that we end up with 6 negatives. So 1 plus negative 7 results in negative 6. So what's the rule then? You guys see, it's the same darn rule as we found from this one. So let's go ahead and just copy this. And we'll go ahead and paste it in here. Okay, so let's check these problems out. Simplifying algebraic expressions. Notice with this guy we've got like terms. We have a negative plus a negative. So if you remember, with like terms, you're going to be combining the coefficients. So a negative plus a negative means we add and attach that negative. So we get negative 13 x's. Okay. All right, so here we're going to end up, we have a negative 6. These are the like terms, right? The negative 6y and 22y. So we have a negative 6 and a positive 22. So which number has the larger absolute value? That's right, 22. So this ends up being a subtraction problem. We will get a positive 16y minus 5. Very good. Okay, here's a couple applications. I don't know if you've ever worked with magic squares, but they're kind of cool little puzzle type things. In a magic square, all the rows, all the columns, and the two diagonals must add to the same number. So the first magic square, you're using the positive integers from 1 to 9. Right? So if you notice, they've completed one row for us. They've kind of helped us out. So if you look, do you see 4 plus 9 is 13 plus 2? Do you see that that ends up being 15? So what you want to do is you want to fill in the rest of these boxes so that you get 15 on the diagonals, 15 on the rows, and 15 on all the columns. So do you guys see that to complete this one, what am I going to have to put? I've got 9 and 1 is 10, so this has to be 5, right? To get my sum of 15. So go ahead and finish the rest of these and pause the movie, finish up the rest of them, and let's see how you did. Okay, guys, here we're back. Let's see how you did. This one's an 8, a 6, here's the 7, and here's the 3. Did you get it? Awesome! Okay, now number two is a little more challenging. These are now we're dealing with integers, both positive and negative, and these are the integers that you're allowed to use. So this one might take you a little bit more time. Go ahead and pause the movie and puzzle it out. Okay, let's see how you did. These are the answers. So we're going to get 4, negative 10, 0, negative 6 and 2, negative 4, 6, and negative 8. How'd you do? Well, if you had trouble on that one, it was kind of a hard one. I even had trouble on that bad boy. All right. So here we go. In high school, an elementary algebra class meets 5 hours a week for 9 months. At Maricosta College, an elementary algebra class meets 5 hours a week for 4 months. The class at Maricosta College has how many fewer in-class hours? So how could we go about filling this out? If you want, go ahead and pause the movie and try to figure it out. For those of you that are a little bit stuck, here's a hint. First of all, let's figure out how many more months. Do you notice that they meet the same 5 hours a week? Right? Actually, as you know, it's only 4 hours a week, but here's hoping that we can make them 5 hours a week. So here we go. We could start by saying 9 months minus 4 months, and that's going to give us 5 months, isn't it? And then there are 4 weeks per month. And we could multiply that by 5 months. And again, we're finding out how many fewer hours. So do you see that these are going to divide out, and this ends up giving us a result of 20 weeks. So now we could say 20 weeks times 5 hours per week, because we want the number of hours that they differ by. And check this out, that's about 100 hours. So this is sort of a study skills, right? So the class at MiraCosta College has 100 fewer in-class hours. That's our answer. But just think about that. If you're straight out of high school, you know, you had a much longer time potentially where you completed this material. And so you may remember that you had a lot of time in class that you could work on assignments. Well, here at MiraCosta College, we have like 100 fewer hours. So what we have to do is we have to lecture and give you the material, and then you have to do like most of your work at home. All right. So just kind of think about that when you are, you know, deciding how many classes to take and how many hours to work, because it really is important to manage your time well when you're in college. Okay, I'll stop being your mom now. Let's finish these guys up. 5 is the good opposite of -5. You could also say additive inverse. On a number line, the greater number is to the right of the lesser number. A number's distance from 0 on a number line is the number's absolute value. Good. Numbers less than 0 are called, good, negative numbers. When using an inequality symbol, the arrow points toward the lesser number. Okay, so go ahead and pause the movie and see if you can work these problems, and then play it again to get the solutions. Good luck! Okay, let's see how you did. This one will be, we can do the -18 plus the -26 to get -44. So this sum ends up in this result. And then the 100 plus 34, of course, is positive 134. So this here results in this guy. And this will yield a result of, for this, notice you have a negative and you have a positive. So you're really going to be doing a subtraction problem, subtracting 44 from 134, and then we'll get a 90, and we keep a positive with it because the larger number, the number with the larger absolute value, is positive. Okay, 12 squared. I don't know if you remember, but 12 squared is the same as 12 multiplied to itself 2 times. And then minus 24 divided by 6. So here we will get 144 minus 24 divided by 6. Now the division has to occur first, so we'll have 144 minus 4, and now we'll get 140. And we're all done. okay. Next up, we have negative 18 plus 2. Now we're going to have to complete what's in those parentheses first. So this is going to give us 45. And then plus 100. In these parentheses, we are going to get 655. Now we're going to need to multiply before we combine the first two terms. So we'll have 2 times 45 is 90. And then 100 times 655 is going to be 655 with 2 zeros at the end. So 65,500. So combining the negative 18 and the 90, we'll get 72. We'll be adding that to the 65,500. And at the end of the day, we will get 65,572. How's it going? Hanging in there? All right, so here we go. 30 plus negative 8 is 22, all over 2 times 176 minus 175 is 1. So we'll get 22 divided by 2, which is 11. We're all done with 1.5. Have a fabulous day.